Hi guys. Hi everyone. Let's go through the protein structure together. So let's talk about the secondary structural properties of protein. That's the general structure of phenylalanine hydroxylase enzyme. Uh, the brown balls represents the iron molecule or non-heme iron binding site. This is where the enzyme activity takes place. Now talking about monomer and secondary structure. As we know that phenylalanine hydroxylase is a tetramer, and that there is a single chain or a single monomer of phenylalanine hydroxylase. Four of these monomer interact with each other, forming a tetramer, which is active form of the enzyme. Moving on to secondary structure of protein domains. So as you can see, the domains are shown in red color. So the first one is N-terminus domain, and it is starts from residue 1 and ends at residue 142. So the red color over there and over here, these two are N-terminus domain. So what they do is they influence the actions of catalytic domain. They are the allosteric regulator of the enzyme. The next one we have is catalytic domain, and it's one of the main domains because it in this domain the enzyme reactions take place. So it consists of 13 alpha helices and 8 beta strands, and it's shown by the color red. You can notice how the iron binding site locates right in the middle of the catalytic domain. So it's where the enzyme activity takes place. The last domain is tetramerization domain, which is made up of one alpha helix and two beta sheets. So here, the job of tetramerization domain is to connect the monomers of phenylalanine hydroxylase and form the active homotetramer. So it's important in forming the quaternary structure of the protein. Now let's talk about the tertiary structural properties. Attachment of iron in catalytic domain. So the iron molecule, it binds to histidine residue his 285, where 285 is the position of the amino acid his 290 and glut 330. So it is attached by three residues. An absence or mutation of the iron binding causes drastic reduction in enzyme activity, which will cause disease that we will discuss later in the topic. So why tetramerization domain is important? It's important because it forms a tetramer, forms quaternary structure like we discussed above, which is important for enzyme reaction to take place. So this shows the connection between uh, the alpha helices of tetramerization domain to form quaternary structure. So that there, circled by red, is a hydrogen bond. Uh, so all the others of them, like these are weak dispersion forces occurring between two alpha helices of different tetramerization domain. So, due to hydrogen bonds and dispersion forces, the chains are held together to form a tetrameric form, which activates the enzyme. Therefore, the formation of tetramer is vital as the enzyme is only active in homotetrameric form. Thank you.